Now that I've shown how we can create our own custom server methods, as well as add HTTP authentication to the HTTP communication protocol, it's time to show how we can use filters, both on TCP/IP as well as the HTTP service. Now we can add filters to the server side and the client side of our DataSnap our applications, so we can compress or encrypt or log or do anything that you want to do with the DataSnap application. Filters can be added to both the TCP/IP and the HTTP communication protocol. In both cases, we should use the filters property, and we can fill them at runtime or at design time. In this case, for the DataSnap server, in the server container unit, I want to add the filters at design time. For filters registered within inside packages, for example, you can add them at design time. You can also always add them at runtime. Clicking on the filter property will add a editing dialog where we can add a new filter, and the filter ID, here we can select from the list of registered filters. In this case there's only one registered filter inside Delphi, the zlib compression. So we can use the zlib compression for this particular TCP/IP server transport. We can do the same for the DS HTTP servers. This also has a filters property. We can click on it, add a new item, and also here select the zlib compression. And now if we recompile and run the server, the DataSnap server application will now use the compression, the zlib compression filter for its communication with the client. Let's now run the client without adding filters, so I can show you what the error message is that you will get when you try to connect to a server which has one or more filters enabled. If I click on the button, we get an error message: communication filter zlib compression is not registered at the client side. So this filter class needs to be registered in order to communicate with the server. Fortunately, if you implement a filter, registration is usually added in the initialization and finalization section of that particular filter component in the filter unit. So, and that's the same thing for the zlib compression filter. So inside our client form, we only have to add to the users clause the name of the unit that contains the filter, in this case DBX compression filter. And that particular unit defines our transport compression filter, and all the way below has the initialization where it registers the filter and the finalization where it unregisters the filter. These are the methods you need to override if you want to create your own filter, and I'll show another filter in a minute. So the client form has a DBX compression filter added to the users clause, and now we can run the client, and this time there's no error, but the communication between the client and the server is actually compressed. So we have a smaller stream connected from the client to the server. And we'll now show you how we can create our own custom filter classes and how we can add them to the filter collection at runtime. So let's first shut down the DataSnap server application, enable the project, and add a file, the specific log filter unit that I've created. In order to create your own filter, you need to derive a new class from the tTransportFilter class. And then you need to override all methods, and you can implement them, although in fact you only have to implement 2 of them in order to process input and process output to send the data back and forth that's being sent from the filter. I also specify a name for the filter. In this case it's a log filter, simply logging what's going on. And I specify a log filter name to be log, and we can register the filters by name. So this name is important, that's why I specify a constant for it. Now the methods set parameter value, create, destroy, get parameters, everything is just plain almost empty, just calling inherited, create, inherited, destroy. Parameters values, we don't need any parameters for this particular filter. However, process input and process output are important. These functions need to return the data that they get and do something with the data. For example, with encryption and compression or hashing, you can understand that something needs to be done to this data. Returning the processed data in this function, both for the input and the output. In our case, we can just say the result colon equals data, do nothing with the data, but instead log the incoming data, and I can here add some code to add the data to the log file or to an event log or somewhere else, and make sure that we know what data is going on, which data is being sent from the server to the client and back. The ID is our constant log filter name, and here important in initialization I register the filter of my log filter name as well as my type, and in the finalization I unregister the filter. Now this log filter unit has been added to the users clause of my DataSnap server. So inside my server container unit I can now register this filter at runtime, and we can do that in the onCreate event of my server container. Inside the onCreate event we can first add the log filter unit to the users clause, and now I can call the TDS TCP IP server transport 1. It has a filters property, and I'd like to call add filter by name, which is my the name was my constant log filter name. So by name log filter name. So this is the way to register it for the DSTCP server transport, and we can call the same method for the HTTP DS HTTP service dot filters add filter log name filter. So with these two lines of code for both TCP and the HTTP communication protocols, I've registered my log filter. And again, I can run my DataSnap server application, and we can again run the DataSnap client application without having added the log filter. So if I click on the button, we get an error message, communication filter log. The name of my filter is not registered. Filter class needs to be registered, etc. Well, we can register it by adding the unit to the project, log filter. Now the unit is added to the project, and that's enough. It's added to the users clause of the project, so the initialization code is called. And if I now run it, click on the button, now we get the result again. And this time both the client and the server use the zlib compression filter as well as my own log filter. And you can create your own filters any way you like. There are already compression filters, hashing filters out there on the internet. Just install them and use them to get your hands and modify the communication stream that's being sent from the client to the server and back.